just a little flight information. Coming up on the left, we're going to be catching a glimpse. Good afternoon, this is your captain speaking with just a little flight information. Coming up on the left, we're going to be catching a glimpse.
Today we are unveiling our new type of simulator. This one, it's a Wama 172, mainly for IFR flying. IFR is instrument flight rules. The same simulator can also apply to VFR pilots, visual flight rule pilots. We are unveiling it here at Makerere University, and it's getting out to the consumers and interested parties, to atolls and other individuals who would like to have this flight training device. There you go. Why don't you come and join me, have a look at it, circumnavigate it, and see the product itself. This is a flight training device. It's a Wama 172, and I would like to pass you through the instruments. Of course, these are gyro instruments, and we want to see if they can do the job. So now, we're looking at our artificial horizon. Okay, the blue here is the sky, and the brown here is the ground. Okay, let us try to test this. Okay, it's working, and I think it serves the purpose. Okay, next is our altimeter. We have our altimeter running. So say if the ATC comes in with a QNH of 1015. So now, well, let's try to run up these instruments and see if they can serve the purpose, if they're into effect. Okay, of course these are gyro instruments. They are analog on a Wama 737, on a Wama 172. So we want to see. First, we're going to test the artificial horizon. The brown here is the sky. The brown here is the ground, and the blue is the sky. So we want to see if this instrument can serve the purpose. Indeed, it can. So we put it to neutral. Next is the altimeter. Okay. So if ATC clears us for QNH, say for instance of 1015, then we gotta dial a QNH of 1015. Okay, let us see if it really works here. Next is the altimeter. Okay, so for instance, ATC clears us for a QNH of 1015. So we come here and say 1015. This is our QNH. Okay, we are at Vanderboom, lined on runway 29, and of course the elevation for Vanderboom is 4095. So let's have 4095 here. There you go. There you go. Altimeter may serve the purpose. So now, if we want to, next is the DI, the direction indicator. So you want to align the direction indicator together with the compass. So what you gotta do, okay? All right, and we into 9. There you go. There you go. Okay. So let's test out the heading bag. Okay. Okay, and back. So now, before you fly, we know our direction indicator ain't going to let us down. Okay, next we have our viewer, very high frequency omnidirectional range. This is the instrument. Okay, let's test this out. Okay, it's very active, and I think it will serve the purpose. Okay, we have another for redundancy, viewer 2, very high frequency omnidirectional range. 2. So let's test this out. Great. I think it solved the purpose. Then we have our ADF, automatic directional finder. Let's test it out. I think it will serve the purpose. All right. Next. There you go. 118.35 is tower for Vanderboom. Okay. So we have 118.35 locked in as tower. So let us try to dial in the ground frequency. Just more. Okay, so that's it. 118.35 is tower for Vanderboom. Okay, so we have 118.35 locked in as tower. So let us try to dial in the ground frequency. Okay, so that's it. So next, what we're looking at here is the viewer 1 and viewer 2. We know that viewer stands for very high frequency omnidirectional range. So let's pick any frequency of any station, viewer station, put it in here and see if these instruments can guide us precisely to that point. So for instance, we're going to choose a viewer station called Charlie Zulu Victor. And I know for sure the frequency is 114.30. So we swap it up and watch closely here as we swap to viewer 1, nav 1. Okay, there you go, it has changed. Let's apply it to nav 2 as well. It is 114.330. Okay, let's swap it up. And there you go. Now we have proof that this instrument can guide us precisely fly to Charlie Zulu Victor. Okay, so let us try to central up the instrument. Okay, so if we are to fly to Charlie Zulu Victor, then we gotta center the instrument. Any deviation of either to the right or to the left will mean this is a command instrument. Let's fly there. As we reach there, we come back and fly the heading. Okay, like so. 2. So we're flying 2. Right. And center the needle. There you go. So how do we tell that this instrument is really into effect? Okay, we gotta know that if we deflect 10, okay, to the left, we gotta skip 2 points here. And deflect 10 to the right, we gotta skip 2 points. Let's take it out. Okay, first to the left, 2, then back to the center. Okay. Watch closely. We are around here. By the time we deflect this end, okay, or this way, we shall have skipped 2 sticks. All right. Now let's do it. This instrument is alive. This instrument can guide us precisely to Charlie Zulu Victor. Okay. All right. So next we have our ADF. ADF stands for automatic directional finder, and the station is called the NDB NDB is non-directional beacon. So it radiates beacons 360 degrees, non-directional beacon. All right, let's try out the NDB4 Whisk Bravo. The NDB for Whisk Bravo is 57257. Let's swap it up. Watch closely here as we swap, okay? There you go. Okay, that means we have to fly this heading to reach the NDB. Okay. Next, we want to have a look at the throttle controls. Okay. Okay. So we have our throttle quadrant that has the throttle, the cabin, and the mixture together with the flaps. Okay. Start with the throttle quadrant. Okay. This is the throttle. Just like you would have a gas pedal in the car. This is the, and always power manipulates speed, altitude. Okay. Power manipulates altitude. So this is the RPM, rotation per minute. RPM, rotation per minute. So we want to know how our propeller rotates per minute. This is it. So apparently our propeller rotates 1,000 times per minute. Okay. So when we have full power, our RPM increases. Okay, with full power, our RPM increases, all right? So we cut the power, the RPM decreases. Okay. So next, we have our cabin, okay? Cabin will always help you de-ice the plane, okay? You always come in with cabin on final approach, just to eliminate the element of icing. Next we have our mixture, okay? This is our mixture. And next we have our flaps, okay? This is our flap lever. We have 20 degrees of flaps. We have 4 flaps, okay? Then 20 degrees of flaps, 10 degrees of flaps, and flaps out. Next, down here we have our trim wheel. This is our trim wheel. We always know that trim will manipulate speed. Okay? We have a fuel selector, right? We have a fuel selector. There you go. You always have it on the left when you're pre-flighting, and have it on the right when you're taxiing. When you're gonna take off, then you have it centered. All right. So our fuel selector is centered. Next, we have our. We are looking at our fuel. We are looking at our switch panel. Okay. First, we have our fuel pump. Next, we have our rotation beacon. Next we have our landing lights. Next we have our tax lights. We have our nav light. We have our throb light. And we have our speed or heat. Okay. Up there. At the extreme of the tail there is what we call the rotation beacon. Let me speed it up and have a look at it. There you go. That's the rotation beacon. And rotation beacon out, we out. Next, we're having the landing lights. So next, we're gonna have our landing lights before us. All right? Okay. There you go. All right? Now let's switch on the landing lights. All right? There you go. We have our landing lights. Our landing lights out. Okay? Landing lights on. Alright. Next, we want to have our tax lights. out, tax light off. Now that tax light will help you when you're taxing, okay? So for instance, it's not, it's coming evening like it is, those are the tax lights. Kind of don't go fit the tax lights with the landing lights, okay? Let me remove the tax lights. And these are the landing lights, alright? Alright? The landing lights are on the extreme right, and the tax lights are on the extreme right. Okay. Next, we have the nav lights. There you go. Those are the nav lights. On the left, it's green. Come around on the right. Right. On the right is red. There you go. Okay. This helps you know that this plane is really coming before me if it's red or blue. If it's same color, this plane is getting away from me. Okay. Then, last we have the strobe lights. Okay? Those are the strobe lights. Okay. Yeah. As we wind it up, we have our control column here, and this is the yoke. Okay? The yoke, we have our electronic trim. You can either just use this or choose the other. Then down here are the rudder pedals. Alright. Down here are the rudder pedals. Alright, ladies and gentlemen, now why don't you join me up, take up a flight with this machine, see if we can actually fly to Charlie Zulu Victor. Okay. So. Alright, let's have our tax checks right. As we tax to the right, the ball is going to swing to the left, the wings are going to swing to the right. There's going to be a decrease in the DI and a decrease in the compass. The artificial horizon is going to be stable. As we tax to the right, the ball is going to swing to the right, left, the wings are going to swing to the right. It's going to be an increase in the DI and an increase in the compass. The artificial horizon is going to remain stable. As we tax to the left, the ball is going to swing to the right. There's going to be a decrease in the DI, a decrease in the compass. The artificial horizon is going to remain stable. We rotate at 55 knots. We climb and ascend at 70 knots. We descend and approach at 70 knots. In case of an abnormality, just after we've taken off, we're going to cut the power. In case of any discrepancy, before we take off, we're going to cut the power, apply brakes, vacate the runway, and advise ATC. In case of an abnormality, just after we've taken off with sufficient runway ahead of us, we're going to cut the power, trim 70, apply flaps, land the plane, apply brakes, vacate the runway, and advise ATC. In case of an abnormality, just after we've taken off with insufficient runway ahead of us, we are going to use speed, field, fault, flaps, and final. We are going to get our speed of 70 checked, left or right, 30-degree angle, trace of a field of landing. It is then after that we are going to check for the fault. Fuel selector checked, mixture checked, carbureting checked, power checked, magnetos checked, all checked. Then we apply the first notch of flaps in consideration with our field of landing. We keep the seat belts and hinges on, open the door, Apply the second notch of flaps in consideration of our field of landing. You field selector cutoff, mixture cutoff, cabbage cutoff, power cutoff, magnetos cutoff, we land ahead. So tower is cleared to take off on runway 06, and there you go. So we've been cleared to take off on runway 06. Okay, full power. NPs and Ts are in green. RPM is 2100 and above. Airspeed is alive. 55 knots. We rotate. And we are maintaining runway heading. Nose on the horizon. Remember, we are flying to our VOR station, that is Charlie Zulu Victor. So this being a command instrument, let's fly a few degrees so that we catch up with it straight here. Okay. So when this needle comes back into center, then we can resume flying our heading of 135. See now, the needle is coming back to center, then we can resume back. So at the needle centers, we shall go back and fly a heading of 135. So let's go back and fly a heading of 135. Okay. So we are flying there. And we are straight and level.